In this video revision lesson, we will be continuing with section B of paper 2. Section B of paper 2 for the Cameroon GCE A-level chemistry. Section B is on inorganic chemistry. So as we will be continuing with section B of the question paper, I will first of all apologize for the poor quality of the question paper I received. So we will be starting with question 4. This question concerns the D block elements, sulfur, nitrogen, and group 4 elements. Before continuing with our revision lesson, I want to appreciate those of you who have subscribed to our channel. And for those who haven't subscribed, please, we need your support so that we can continue assisting you by providing you resources for your revision. Thank you for your collaboration. Please like, make comments, and share with other fellow learners. Welcome back. Thank you for taking your time to do that. So we go straight away to question number 4. This question concerns the D block elements, sulfur, nitrogen, and group 4 elements. Distinguish between a D block element and a transition metal. A D block element and a transition metal. Okay, if you look at it critically, a D block element and a transition metal, though all of them are within the D block, but not all the D block elements are transition metal. Not all D block elements are transition metal, because there is a specific difference which I want to give you on this. And the main difference between a D block element and a transition metal is that a transition metal forms one or more stable ions with an incomplete subshell, that is incomplete d orbital. Transition metal form one or more stable ions with an incomplete d subshell, or what we call d orbital. Whereas D block element form only one ion with either a completely filled or an empty D subshell. I said here, let me just put it there. I said a transition metal, a transition metal, forms one or more stable ions one or more stable ions with an incomplete D subshell, what called D orbital, a D subshell. Whereas whereas D block, whereas a D block element, whereas a D block element forms only one ion, with either a complete with either a completely filled or empty d subshell or d orbital. An example of these of the D block element I can talk of, e.g. scandium and zinc are D block elements. They are not transition metal. E.g. Let me use scandium. Scandium has an electronic configuration of A, that is argon, with 3d1, then 4s2, with 4s2. And when it forms an ion, when scandium forms an ion, let me say all the 4s electron and the 3d electron are lost. In that case, scandium now has a filled d orbital. Scandium now has a filled d orbital. In the case of zinc, zinc has an electronic configuration of with 3d10 and 4s2. So now when zinc forms an ion, all the 4s electrons are lost. So it will be zinc 2 plus. It will be a zinc 2 plus, and it will be left with what? Zinc 2 plus, it will now be left with a filled, zinc now will be left with I'll fill this. So now sorry, made a mistake here. When these two electrons are lost, yeah. The one has no. Okay. Now, take for instance, I said the question says distinguish between a D block element and a transition metal. Not all elements in the D block are transition metal. And that is why I am saying that a transition metal forms one or more stable ions with an incomplete d subshell, with a d orbital, whereas a d block element forms only one ion with either a completely filled or an empty d orbital. For instance, I'm giving an example of scandium. Scandium has argon plus 3d1 and 4s2, and when it forms an ion, it forms only one ion with what? With an empty d, it has no d subshell. It forms only one ion with no d subshell. Then again, ion 2, ion has 3d, argon 3d, 3d10 and 4s2. Now, ion forms an ion by losing all the 4s orbital electrons. So it has only 3d. So ion form is ion 2 plus with what? With a full d subshell. So that's why I said, whereas a d block element forms only one ion with either completely filled in the case of ion or empty d subshell in the case of scandium. So that is the only major difference. You can't be saying that transition elements form colored compounds, they act as catalysts, variable oxidation state, or they form complexes, whereas d block elements do not. Well, some examiners will take that. If you say a transition metal forms colored compounds, act as catalysts, form variable oxidation state, form complexes, whereas d block elements do not. Well, at a certain level, some examiners might take that. But what I give here is a transition metal. They form one or more stable ions with an incomplete d subshell, whereas a d block element forms only one ion with either a completely filled or empty d subshell. I gave an example of d block element as scandium and zinc. These are the only two elements that are not transition metals. The rest, from titanium to nickel, are all transition metal. But scandium and zinc are they are not, they are only D block, they are not transition metal. For purpose of revision, if you look at all of them, you see they have partially filled D subshell, partially incomplete D subshell. They look at their oxidation, common oxidation state. All of them have at least one. It's only nickel. The rest, they have more than one oxidation state. So that is why I have given you this. They will form one or more stable ion with an incomplete D subshell. Either you call it D subshell or call it D orbital. Incomplete D subshell, whereas D block elements form only one ion with either a completely filled or empty D subshell. Example, you can say scandium and zinc are D block elements. Yeah, and if you did that, you will have, I think it's about 2 mark or 1 mark. Write down the symbol of the elements of the first transition elements of the first transition series in increasing order of atomic number. Transition series. The elements of the transition series, write down symbols of the elements of the first transition series in increasing order of atomic number. Okay, you will have titanium, transition series. You have titanium, which is a titanium, I think that is 22. You have titanium. This is, yeah, titanium, vanadium. You will have titanium, Ti, vanadium V, chromium, and manganese will follow. Iron will follow. Cobalt will follow. Nickel will follow, and you end up with copper. These are what we call the transition metals. Write down the symbol of the elements of the first transition series. Okay, state the property of transition elements. State the property of transition element. State the property of the transition element which enables them to act as catalysts. Okay, you know that transition elements, that property that will enable them to act as catalysts is the property of the transition element that will allow them to act as catalysts. You should know that a catalyst in a chemical or industrial process, their major role is to lower the activation energy of a chemical reaction. In any chemical setting, the main role of a catalyst is to lower the activation energy. For that purpose, the property, that property that enables them to act as catalysts in many industrial settings is that they have variable oxidation states. They have variable oxidation state. You can just take the variable oxidation state. The variable oxidation state, that property is variable oxidation state. Variable oxidation states. State the property which enables them to act as a catalyst. They have variable oxidation state. Why do I say they have variable oxidation state? Because the ability, this variable oxidation state, it will give them that ability to change oxidation state and exist as one or more ions. So variable oxidation state is one of the property. Or again, or you could say they have that ability to form complex ion, ability to form complex ions. Variable oxidation state or ability to form ability to form complexes. Ability to form complexes. That ability to form complexes enable the catalyst, enable them to form intermediates in a chemical reaction. So it will enable them to form reaction intermediate with suitable reactants. So you can either say they have variable oxidation state. A variable oxidation state is a property, or you can say ability to form complexes. Either of the two is good. That's a good property that will enable catalysts to act in an industrial setting. So C part, give the formula of fertilizer. Give the formula of a fertilizer containing nitrogen and sulfur atoms, and state the oxidation state of nitrogen and sulfur in the compound. Or, of course, most rich fertilizer, they contain nitrogen and sulfur and phosphorus, but the one that contains only nitrogen and sulfur, we can have it as a good example of it is something like ammonium sulfate. Ammonium sulfate is a good example. We can say ammonium sulfate. Ammonium sulfate is something like this: NH, NH, yes, 2 SO4. Call it ammonium sulfate. Ammonium sulfate. Ammonium sulfate is a good example of a fertilizer containing nitrogen and sulfur. Now, if we oxidation state of nitrogen, if we want to calculate oxidation state of nitrogen in this compound, let's see. Nitrogen, ammonium sulfate, this is nitrogen. Ammonium sulfate. if we want to calculate for nitrogen here, there are many ways we can calculate it. For nitrogen here, remember sulfate has an oxidation number. This is a radical. It has an oxidation number of -2. So here, let me take nitrogen. Because there is a 2 outside here, I will say nitrogen is 2x, and this is a neutral molecule. Nitrogen is 2x. The oxidation number for hydrogen is 1. 1 times 4 is 4. 4 times the 2 outside is +8. Is +8. Remember, the oxidation number for sulfate as a radical is -2. And according to the rule, the sum total for the oxidation number of a neutral molecule is 0. Now, if we want to find for x, it will be that is 2x plus minus equals to -6. Therefore, x will be equals to what? X will be equals to -3. So nitrogen here will be -3 in this. Nitrogen will be equals to -3. Now again, you can another method to solve this here is by just using the sulfate alone. By just using the sulfate, the ammonium alone. For this alone, we will say nitrogen is 2x. Hydrogen is 1. 1 times 4 is 4. 4 times 2 is 8. Is +8. It's +8. And the total is now is +8. Is +8. The total is not 0. The total is not 0. But remember, if we are using this, we must use the oxidation state for ammonium. And the oxidation state for ammonium radical is +1. And since there are 2 ammonium, it should be +2. So in that case, we will say it is 2x, which is equals to, this comes here will be -6. -6 plus -8 plus 2 is -6. So x will still be equals to what? -3. So either you use this, and when you use this alone, assume it to be equals to the oxidation number for ammonium and times 2. There are 2 of them there. But I prefer just use this one by calculating it and taking the oxidation number for the radical to be -2. Now again, let's calculate for sulfur, the same method. If we want to calculate for sulfur in the same method here, we will say ammonium is -2. Since ammonium is negative, if we want to calculate for sulfur, ammonium is -2. So what happened will be ammonium is +2, sorry. Is +2 because ammonium is +1. +1 times 2 is +2. Is +2. So we say it is 2. 2. Now, sulfur is just 1. Sulfur is just 1. So plus x. Sulfur, let's assume sulfur to be x, is x. Then oxygen is -2. So -2 times 4 is -8. Is -8. So now, which we give it equals to 0. So x, 2 plus 2 minus 8 is -6. Is -6, which is still equal to 0. X now will be equals to what? Is +6. So we can now say that sulfur is +6. Sulfur is +6. Sulfur is +6. Another way to calculate sulfur like we said here, this is sulfur from in sulfate. If we are calculating sulfur in sulfate, we must assume the oxidation state for sulfate. Therefore, we can now say sulfur is X. Sulfur is X. Now oxygen is -2. So -2 times 4 is -8, which is equals to, assume we have to will be equals to the oxidation state for the sulfate radical. The oxidation state for the sulfate radical is -2. Now X will be equals to what? This way will be equal to plus 8 minus 2 is plus 6. So there are two ways you can do it. There are two ways you can do that. You can assume the whole total molecule and calculate it from there, or you take it individually and equating it to their oxidation number, and you get it. Okay, it takes us to the D part of it. It takes us to the D part of it. Give two differences in chemical property between carbon or its compound, and the rest of group 4 elements. Two properties and the rest of group 4 elements. So now the properties here, are now the differences between carbon and other group 4 elements. One, we can say carbon. You can say carbon has that ability to catenate. Carbon has the ability to catenate. Carbon has the ability to catenate. To catenate. That ability to catenate, that is to form chains or ring with itself. Carbon has the ability to catenate. Another one is that carbon has 4 valence electrons used for forming 4 different bonds. Or you can just say this is 1, 2 differences 2. Carbon can form single, double, and triple bond. Can form single, double, and a triple bond. It can form single, double, and a triple bond. Now, another one is carbon can form 4 chemical bonds to other atoms. It can form 4, that is sp3 hybridized. Can form 4 bonds. Can form 4 bonds, or chemical bonds. Can form 4 bonds. 4 bonds to other atoms. In that case, we can say sp3 hybridized. Carbon is sp3 hybridized. It can form 4 chemical bonds to other atoms. It can form single, double, and triple bonds. It has the ability to catenate. You can give 2 of them. That is the only thing. That is all there. D2, catenation and inert paired are 2 phenomena that characterize the chemistry of group 4 elements. What do you understand by catenation? Yes, we have used catenation in the first place. So what do you understand by catenation? catenation is the ability of an atom to form chains and rings between itself. Ability, can say ability of an atom, ability of an atom to form chains and rings, chain and rings, that is covalent bonds, chain and rings between itself, e.g. we are talking of this carbon-carbon ability to form between itself, carbon-carbon bonds, bonds. So the ability of an atom to form chains and rings between itself is what we call catenation. Then another one is, what do you understand by an inert paired effect? Inert paired effect. An inert paired effect. Yeah, an inert paired effect. This is a phenomenon. It is a phenomenon where the two electrons in the s orbital remain paired. Two electrons in the s orbital, they remain paired and do not participate in bonding. Let me put it this way. Inert paired effect, I can say a phenomenon where the two electrons in the s orbital or in the s subshell, in the s orbital or s subshell remain paired. That is something like this. Yeah. So they remain paired. And do not participate in bonding. Because to participate in bonding, you need to unpair them. Either you need to promote this one to annex to a higher energy level. To unpairing them will require a high energy. So they remain paired and spinning in opposite direction and do not participate in bonding. I can say the reason is that so now an inert paired effect, we are saying that an inert paired effect, this is a phenomenon. It's a phenomenon where the two electrons in the s orbital, they remain paired and do not participate in bonding because high energy is needed to unpair them. If you want to unpair this electron in the s orbital here, you need to promote it to a higher energy level, to another higher energy. It has to be promoted to higher energy, and to unpair a paired electron here will require a high energy. So this is what we call inert paired effect. They don't take part in bonding. because high energy is needed to unpair them. Okay, it takes us to explain why carbon shows a very high ability to catenate. Ability of carbon to catenate. That is, ability of carbon to form chains and ring between itself. Why? Explain why it has that ability. The simple explanation for this, a simple explanation for this, that ability for carbon to catenate is due to its small size. You can say uh, ability to catenate is because of its small size. Because of its small size, the small size of carbon, which makes a carbon-carbon bond very strong. Which make the carbon-carbon bonds carbon-carbon bonds very strong. Yeah. Explain why carbon shows a high ability to catenate. I said the ability of carbon to form chains or ring, that is to catenate, is because of one, because of its small size, which makes the carbon-carbon bond very strong. Another reason for it, number two, I can say, another reason is because carbon has oxidation number which is above +2. Carbon has oxidation, I can say oxidation number, has oxidation number greater than +2. That is the ability. Why carbon shows a high ability to catenate? Because of its small size, which makes the carbon-carbon bond very strong. Because it has an oxidation number which is greater than +2. It takes us to the E part of it. The E part of it, which is the E part of it. The E part of it. E part of it says. The E part of it says that group 4 elements also exhibit allotropy. What is allotropy? What is allotropy? Or what is an allotrope? Yeah, you can define allotropy as existence of an element in two or more forms. Existence, you can say allotropy is existence. Allotropy is the existence. You can say existence of an element. Existence of an element in two or more forms. Two or more forms in the same physical, state, in the same physical state. Let's say in a crystalline state, in a solid state, in the same physical state, but differ in their physical properties. Differ in their physical differ in their physical properties, although they will have the same chemical properties. So I can say allotropy is the existence of an element in two or more forms in the same physical state, that is a solid, but differ in their physical properties. Yeah, their physical property have have same chemical properties. So they exist in two or more forms in the same physical state, but differ in their physical properties and have same chemical properties. So the major thing here is an element existing in two or more forms, physical states, and they differ in their physical properties, but same chemical properties. Okay. Um, in that case, well, you have been asked to give examples. You have been asked to give example. If you were not asked to give example, you can even give example for the examiner, encourage the examiner to give you more marks. So the second part of it, give two crystalline forms of each of the following group 4 elements. Carbon. Carbon will exist as the crystalline form of carbon, even though there is um, fullerene. There is fullerene in carbon, but as crystalline, but in a crystalline form, carbon will exist only as a diamond and a graphite. Carbon would exist as diamond in a crystalline as diamond and graphite. We cannot include fullerene there. So it is in a crystalline form, it is diamond and a graphite. Okay, tin. Tin is another example. Tin, they have different crystalline form of tin. There is white tin, there is white tin, and that white tin, we call it alpha. We call it white. There is white, which we call it beta. It's beta tin, white or beta tin. Is beta tin. This one, this the crystalline form of this allotrope is it has a tetragonal shape. It has a tetragonal shape. Yeah, it has a tetragonal shape. We also have the alpha tin, which is a gray. The crystalline form is a gray tin. The other one is white tin. In that case, we call it either we call it white tin or we call it beta tin. The other one, another crystalline form of tin is gray tin, or we can call it alpha tin. Alpha tin. This one is cubic. This one is cubic. It has a cubic shape. It has a cubic shape. Cubic shape. It has a cubic shape. There is another one. There is another one. There is another one. We call it. There is another one which is, which it has a rhombic shape. A rhombic shape. There's another one that has a rhombic shape. So, if you can say there's white tin or alpha tin, and you can say there is gray tin or sorry white. There is white tin or what we call beta tin. That is one of the crystalline form of tin. Another crystalline form of tin is there is gray or alpha tin, gray or alpha tin. So there is beta tin and there is alpha tin. You can say there is white tin and there is gray tin. So these are crystalline forms of tin. Unlike in carbon, we have but diamond and graphite. We have but diamond and graphite. So these are the only forms of carbon that we have. And by answering all these, you will have a total of, give you a total of 20 marks. This was June 2020, paper 2. June 2020, paper 2. A recap. They said distinguish between D block elements and a transition metal. I gave an example to you. Look at transition metals, look at their electronic configuration, look at their electronic configuration. They form 1 or 2 ions and they will what? Incomplete d orbitals or d subshells. But for d block elements, remember, not all the d block elements are transition metals. That is why I said a transition metal forms 1 or more stable ions with an incomplete d subshell, whereas d block elements form only 1 ion with either completely filled or completely empty d subshell. And the one that has completely filled d subshell is zinc when it forms an ion. And the other one that has completely empty d subshell is scandium when it forms an ion. So that is the difference. But I said, you do mention that transition metals, they form color compound, they have variable oxidation state, all those things like that. Well, some examiner may have to take that, but this is the major difference. Okay, I went further. Said write down the symbols for the elements of the first transition series in increasing order of atomic number. Of course, scandium and zinc are not included. We will have the element will start from titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper. Those are the transition elements. Now, state the property of the transition metal which enable them to act as catalysts in many industrial processes. There are 2 properties I said. The first property is a variable. They have variable oxidation state, and with these variable oxidation state, as I said, with the variable oxidation state, they will have that ability to change oxidation state, and as is as ion, 1 or more ions. You can either state ability to form complexes. With that ability to form complexes, that enables them to form intermediates in their reaction in the industry. It enables them to form intermediate with suitable reactants in any process. So these are the only 2 properties: variable oxidation state or ability to form complexes or complex ions. Now, give the formula for a fertilizer containing nitrogen. There are many of them, but I was able to come out only with ammonium sulfate. The ammonium sulfate, you can use that to calculate the oxidation number for nitrogen and the oxidation number for sulfur. Then give 2 differences in chemical property between carbon or its compound and the rest of chemical property that has to do with reactivity. And the reactivity has to do with formation of bonds. So that's why I say carbon has the ability to catenate. That is to form bonds, to form covalent bonds in chains and ring within itself. Ability to catenate. It forms single, double, and triple bonds. Can form 4 bonds to other atoms. It is sp3 hybridized. Then, now, what do you understand by catenation? I said catenation is the ability of an atom to form chains and a ring between itself. I will give you an example of carbon-carbon bonds. In carbon-carbon bonds, in aliphatic compounds, and in aromatic compounds, like in benzene and other in aliphatic compounds. So that ability to form chain, like in benzene, ability to form rings, like in benzene, ability to form chain, like in other aliphatic compounds, that is what we call catenation between the carbon-carbon atoms. Now, what is an inert pair effect? I said an inert pair effect. This is a phenomenon where the 2 electrons is a phenomenon where the 2 electrons in the s orbital remain paired. They remain paired and do not participate in bonding due to the high energy needed to unpair them. Explain why carbon shows a very high ability to catenate. Of course, ability to catenate because of the strength of the bond. It has to do with the strength of the bond. So I said the ability of carbon to catenate lies in the fact that it has a very small size, which makes the carbon-carbon bond very strong. You can then add again to say carbon has an oxidation number which is greater than 2. Yeah. And I went further to say the group 4 elements, they exhibit allotropy. What is allotropy? I told you that allotropy is the existence of an element in 2 or more forms in the same physical state, but differ in their physical properties and have the same chemical properties. For instance, diamond and graphite, these are all forms of carbon. In the same physical state, they are all crystalline solids. They are all crystalline solids, but they differ in their physical properties. The other one is harder. The other one is harder, and the other one is softer. Diamond is harder. Graphite is softer. Graphite can conduct electricity because of the localized electron there, but graphite cannot do that. But diamond cannot conduct electricity. That's why I say, but differ in their physical properties and have the same chemical properties. Then we went further again to say, give 2 crystalline forms of each of the following: carbon, as we have said, diamond, and the graphite, but don't include fluorine there. It's diamond and graphite. Tin has 2. There's white tin and there is gray tin. You can either say there's white tin or there is gray tin, or you can say there is beta tin and alpha tin. These are 2 crystalline forms of tin. I think that is over. I want to thank you for listening. It's a great pleasure. But before I go, I just want to remind you that for those of you who haven't subscribed to our channel, please like the video, share to other fellow learners. We very much appreciate your comments, but remember to hit the notification bell. Wishing you best of luck in your exams.